In my end of quarter video for winter 2019, I talked about the motivation for the problem scaffolded exercises is addressing more generally. In this end of quarter video, I would like to talk about the motivation for the specific problems I was addressing this quarter. For quick context on my project, Scaffolded Exercises transforms professional websites across the internet into learning opportunities by automatically providing exercises tailored to the code at hand. These exercises scaffold learners to be able to break down a large code base, understand conceptually challenging portions of the code, and recreate professional programming patterns contained in the example. I'd also like to quickly review my work from the previous quarter and give you context for my work this spring. So I spent the first part of winter quarter enumerating everything a user needs to know in order to be able to recreate the click-drag XKCD comic example. To do this, I conducted user studies to find out what our user needs in order to write professional level code and what they lack given the existing tools, like Chrome Developer Tools and Isobleath, for example. Given that need finding, I started to test some low-fidelity interface models created to address some of the obstacles my user testing uncovered. The preliminary prototype I tested had some basic exercises, but there was no type mapping in the specific obstacles I was solving with those tools. Further, there was absolutely no scaffolding to help a learner decide when to use a given tool. Finally, these tools were very low fidelity and hard to test for that reason, so going into spring, I wanted to improve and test my interfaces. So now it's spring, and this quarter I started by enumerating really technical outcomes I wanted a learner to be able to achieve, and I mapped more closely than I had in the winter a series of exercises to those obstacles faced by learners in achieving the technical understandings I wanted them to. So the way I did it was creating a unique tool for each obstacle, and I'll show you them here and then go into why I changed my approach slightly and what that looks like now. So right here, this is a list of some examples of the technical outcomes I was looking for. And you can see just how code-focused these outcomes are, which was helpful while I was starting to think about the interfaces to help achieve these outcomes. But as I'll talk about later, these outcomes don't really address the core problems that make it so hard to understand and write professional level code. So here is a list of all the tools a learner had access to. In all, I created about 7 different types of exercises to help a learner work through professional code. We'll quickly touch on each before discussing my recent redirection, since that redirection still involves a lot of this current work. I won't get into the setup or study procedure that I used to test these interfaces, but high level I relied heavily on Google Docs to create a sense of aliveness and interactivity. So for example, a user would answer a question and I would paste in the next question corresponding based on their previous answer. Okay, so jumping into exercises. The first one was macro structure questions, which I talked about pretty extensively in the winter quarter status update video, so I won't get too far into it. But the idea is that you get a high-level understanding of the different components of a program that's still more code level than Isobleath is. It really requires code reading. And it's the only exercise that is required, and it is always the first exercise. So another exercise option is the live workspace, and functionally this works much like editing JavaScript in the sources pane in Chrome Developer Tools, but it was important for me to enumerate this as an exercise option because users need an authentic learning environment to combat writing code in isolation from the rest of the system, writing code that doesn't account for or consider the larger ecosystem that the code will run in, and the fear of changing or breaking existing code. Another exercise option is tutor-ons, and tutor-on handles the problem of people not knowing JavaScript or library syntax by automatically offering documentation for that specific syntax that a user might not know, which reduces context switching and increases the likelihood that the learner will get the right information right away, which clears up confusion and allows the learner to continue making efficient progress. Tutor-ons is the product of existing HCI research, so it's not novel, but I found it to be important in the context of our suite of tools, which is novel. The next one is I understand and fill in the blank. And so users need to be able to layer understanding themselves in order to understand the whole picture of a program. So this exercise prompts users to reflect on what they understand and test their perceived or self-reported understandings. As a user works through the exercises, the other exercises, they are prompted periodically to mark the pieces of code that they now believe they understand in this exercise, which kind of is persistent, so it goes on. It's not just do it and then move on. So at any time during the exercises, a user can also signal that they want to practice code writing. And one way they can do this with scaffolded exercises is by completing the second portion of this exercise. So based on what a user has marked as understood, the system removes portions of the code related to that understanding and asks the users to quote-unquote fix the program based on their understanding so that the program runs correctly again. This provides a nice intermediate bridge between the code reading and writing all by themselves. So this exercise in particular seems like it has a lot of promise, but it also has a lot of ambiguity. So for example, if you say that you understand a variable, but you only mark that understanding in one function, can the system give you an exercise related to that variable, but in a completely different part of the code? And what does it mean to truly understand? All these things kind of are still unclear. So the next one has to do with the idea that variables are used in so many different contexts in a program, and there are many different conceptual components to a program, and the large amount of code displayed in the code base at any time can be really overwhelming. So for this reason, I wanted to make an exercise that makes it easier to find and relate instances of code writer, so like the user wrote the code and that content is what's defined. But after receiving feedback, this tool really already exists in Isoplex, so it's less important to actually create in scaffolded exercises because it almost feels like reinventing the wheel, but in a way that might just be a little more confusing in the context of so many other exercises. So the next one is helping to understand how a program is running. So in this, users have to be able to connect how their actions affect the system. So live value inspection shows the value of different variables as a user interacts with the example. And even further, it allows a user to change the value of a given variable at any time and see that live update, which isolates one part of the code directly. So if I change a variable, I can immediately see what that looks like. And I can either change it manually by typing in a new value or by dragging and working in the confines of a user might normally work with that exercise. With that example. So the next thing is, if we want to support the translation of our understanding of code to actually writing code, we need some intermediate step that decreases the labor-intensive work of syntax specificity and instead captures the conceptual understanding in some sort of pseudocode. So Parsons problems break up functions or other JavaScript components into smaller pieces that are then meant to be ordered so that the component would run correctly if put in the live code. So here's an example of a perfect translation of the blocks on the previous slide right here to a correctly ordered Parsons problem solution. So you can see that there's correct indentation and that there's specific ordering. So most of these tools worked in some capacity for the very specific obstacles they were made to solve, but still there were no solutions built specifically for an outcome. It was just per obstacle and a little bit scattered. So I was missing two really important components in this beginning prototype. First, an outcome-specific tool so that a learner would finish an exercise and achieve a specific outcome. Second, I was missing any sort of process management. So these exercises left learners to fend completely for themselves in trying to move through their understanding of the code and really didn't give them much direction on what might be a good tool to use at any given step. So after getting feedback on my prototype, I went back to working on my design arguments, trying to get at what makes this example conceptually difficult beyond just the technical challenges. From there, I would be able to start working to create comprehensive exercises that overcomes these conceptual blockers so that you can come to the conceptual outcomes that can then be carried across examples beyond just XKCD. So the way that I've been recently thinking about getting to the core concept of a given piece of code works something like this. So I have a piece of code and a bunch of corresponding questions about why that specific piece of code is hard, but the question is why those pieces are hard and what makes it so challenging beyond just technical implementation to understand and recreate this code. So that answering that question gives us the concept, and that is the outcome I ultimately want the learner to understand. From that understanding, I can craft characteristics to move towards the outcome, to move a user towards that outcome. So it all sounds like magical and easy. If you can come up with the code and the question, then you have the concept. But when working on this, I got pretty blocked for a few reasons. So first, I was trying to do the process for all of the XKCD code, which just wasn't feasible or even helpful before I had tested kind of this method on a smaller slice. So the first thing I did was slice down the XKCD code to only work on this kind of workflow process for one part, for one function, which is the drag function in the XKCD code. My other biggest blocker was coming up with characteristics associated with the outcomes I was identifying. The main reason I was having this blocker was because my outcomes were really the questions. It was, the second step after picking the code that should prompt the outcome. So once I could understand the underlying reasons those questions were even surfacing, then I was able to just start to create corresponding characteristics. So I spent a lot of time updating my design arguments to focus more on conceptual challenges associated with the technical work. And now I want to start translating that work into updated interface arguments based on the characteristics I started to identify from coming up with those real deep conceptual challenges. So that way I can build out a low fidelity prototype next and be able to test my hypotheses that come with the new design arguments. And that next bit of feedback will be instrumental in helping me continue to shape and refine the research as I did in being able to test my prototype this quarter. Thanks so much for listening.